Hello, so this question is find the k-or of an array. So basically you give an integer array and also the integer k. So what you need to do is basically you want to know there's at least k numbers in the nums have a 1. So let's just quickly go over it. So this is number in the nums array, so 7, 12, 9, 8, 9, 15. So if you do written down in binary, it's gonna be 0, 1, 1, 1. And then once you list out everything, then you need to count the number for 1 in this column, and then you increment if they, you say equal to 1 if this sum is greater than or equal than 4. So this is 1, 2, 3, 4, right? And this is 1, 2, this is 1, 2, 3, this is 1, 2, 3, 4, 5. So only bit 3 and bit 0 is greater or equal than k, so you say equal to 1. So that's pretty much the idea. So what we need to do is we need to have the hash map, and the hash map is going to represent what? Uh, the index. So key is going to be an index, so key is going to be b3, b2, b0, b1, something like this, right? And there's going to be a list, so you need to store this, right? So list of the integer, basically, right? And then you increment. All right, so let me just quickly dive into the solution. So hash map integer, list of integer. Let me just call map. So we need an index for sure. So all right, and wait. And I also need another index, so I will say j equal to 0. So think about this. Let's traverse the first one. So while nums I does not equal to 0. All right, so first thing is we need to, generate a list for list index, right? So I'm just say map dot compute if absent, and j is going to be the index. Think about this. We're starting. It's going to be 0, 1, 1, 1, right? And then we definitely need to what? Add in the value from the end to the beginning, right? So we are going to at some point we're going to, shift the binary right by 1 until it's actually 0 when the nums are equal to 0. All right, so at this point, compute if absent at j index, and I'm just initialize the array. All right, so that's it. All right, so now we're going to check if the current nums at I and 1 is equal to 1. So just basically you need this annotation, the parenthesis around it. And then we need to say, oh, map.get at j. If this is equal to 1, we need to increment, right? We need to increment the index. So it's going to be I. And then we shift the I right by 1, and then j++. So j++ will actually define you move into the next index. And then even though we shift right by 1, so we no longer need bit 0, but you need to still doing bit 1, right? So next iteration, the bit 1 becomes bit 0, but technically it's bit 1, right? All right, j++, and then this will iterate until the nums are equal to 0, and then you do the second nums, right? The second nums is going to be what? It's not equal to 0, right? So you basically check, do I have the array list? If I do, I'm not generate a new array list at this index, and checking is the current value is equal to 1 or not. Currently it's not, right? So we shift right by 1 and j++. So it come here, and it's still not, then it comes here. So now it's actually what? Equal to 1, right? And then at this point we know j equal to what? 2. So at 2 we need to add what? I is what? 1, right? So this is adding the number of the nums that satisfy this bit column. And later on, we just want to double check. So I need to return the result. Oh, so I want to return a result if map.entry and then integer list of integer entry map.entry set. All right, I'm iterating one whole entry at a time. So if my list the size is greater or equal than k, I know it's going to be what? It's going to be say equal to 1, right? So entry dot get value dot get size is greater or equal than k. Then I can do the power, right? So I don't need to get 1001. I can actually 220 plus 221 plus 222 plus 223, and then depending if this is 1 or not, right? So if that's the case, I can just do this. If this is correct, result is going to be plus equal math to power, and then it's going to be base 2, and then you depending on the key, right? So it's going to be entry dot get. This is going to be 2 to the power of 3, right? So it's going to be based on the key. So entry dot get key. So this is pretty much the solution. Oh, shift right. There's something x. Wait, what's x? X is 2. Base 2. Yeah, that's it. That's the solution. And for the time and space, time, this is all of n. This is going, and then this one is going to be depending on what is the largest value in the nums array. So I would say all of n times, and this is definitely log, right? Log base 2 every single time you shift right by 1. So it's going to be all of n times log base 2 m. M represent the maximum value in the nums, and this is going to be all of n straightforward. So the worst case is going to be this, all of n log m, and then space is only this, right? So all of n only. So this will be a solution, and I'll see you later. Bye.